we perform various types of muscular activity. We are sitting there, writing, listening. This also requires muscular activity. While sleeping, you also require energy. Sitting, walking, running, every activity requires energy. And the requirement of energy, how much energy will be required, it will depend on the intensity of the muscle contraction. Now, how this intensity of the muscle contraction, muscular activity can be graded? There are several criteria of grading muscular activity. During muscular activity, muscle contraction, we need ATP. We need ATP. We have seen in a muscle, when a muscle undergoes contraction, even relaxation, the muscle will require ATP. Firstly, the ATP is required for activation of myosin head. So there is an enzyme. This enzyme must be activated. Myosin head contains an enzyme. This should be activated. So for activation, when there is activation, there is energy must be needed. So there ATP will be needed. Then it will form cross bridges, and for every stroke requires one ATP. So there also we require ATP. Again, the ATPs are required. So lot of calcium ion will be entering. Otherwise, from extracellular fluid or through sarcotubular system. So they will be entering within the sarcoplasm. But normally in sarcoplasm, their concentration is very less. Calcium ion is needed for initiation of muscle contraction. If it remains within the muscle cell in high concentration, muscle will remain in a contractile state, as we have seen in rigor mortis. So normally they should not be, if muscle is not contracting, the calcium ion should not be present in the cytoplasm. We have seen, but we will see, there are different ways by which, particularly in smooth muscle, calcium ion enters within the sarcoplasm by various means. But in skeletal muscle, there is only one mean, only one process. That is true when an excitation will be coming to sarcolemma and this will be entering into the sarcotubular system. There it will cause activation of calcium channel. Now this calcium will enter from ECF into the cytoplasm. While entering into the cytoplasm, this calcium ion will cause release of calcium ion from the sarcotubular system. Now, from both sources, one is from the sarcoplasmic reticulum. So one source is sarcoplasmic reticulum. So within the sarcoplasmic reticulum is endoplasmic reticulum of muscle cell. So they contain, their function is to store calcium ion whenever needed. So calcium ion within the cell can come from two sources, one from ECF and one from sarcoplasmic reticulum. So we have seen in muscle contraction, from both the sources, calcium ion entered. But amount of calcium ion released within the sarcoplasm is much more from the sarcoplasmic reticulum, not from ECF. However, When muscle contraction is finished, then again this calcium ion has to be sent back to their original position, to ECF or in sarcoplasmic reticulum. Again this will require energy. So we can see ATP is required within the muscle cell for its various activities. Now how this ATP will come? How the muscle cell will get this ATP? There must be some process which will supply. There is continued need of ATP. So how it is to be supplied within the muscle fiber? So there are different sources by which ATP can be availed. One is ATP-CP system or phosphagen system. ATP-CP or phosphagen system. CP, creatine phosphate. ATP is important. Why? Because of its phosphate. It is having 3 phosphates. Adenosine triphosphate. The last phosphate is very important. Why? The bond, the phosphate bond creating with ADP is having high energy. So when this will be hydrolyzed, lot of energy will be evolved. With this energy, any cell in our body can perform its activity. It's like our money. With the money, we can do everything. Without money, you will not be living. Can you live without money? Is it possible? So without money, you cannot live. Without ATP, you can't live. So there is another system, another phosphate ion contained in another compound, that is creatine phosphate. The problem is the creatine phosphate cannot bind with the receptor, with the enzyme that need energy. Only ATP can bind there. So what to be done? The creatine phosphate can donate its phosphate group. This phosphate group of creatine phosphate is high energy phosphate group. So this phosphate group can be transferred to the ADP. But once ATP is used, it forms ADP and inorganic phosphate. So ADP is now devoid of one phosphate bond, one phosphate. So now CP will donate this high energy phosphate to the ADP, so that ADP becomes ATP. So CP is required for regeneration of ATP. Okay? So this is within the muscle cell. For muscular activity, the ATP is needed. At the same time, CP is needed. Why, sir? ATP is there. Why should we use CP? Okay? For a few seconds we did it. For this muscle contraction of very short duration, this contracting muscle will be requiring ATP. And where from this ATP will come? It will come from the amount of ATP stored in the muscle. And this ATP will be exhausted within few seconds, 3, 4 seconds, 5 seconds. With this energy, you can just punch somebody. Okay, so since its storage is very less, so if I want to continue, then what to do? So the ATP that were used, they are already hydrolyzed into ADP and PI. Now, creatine phosphate will come into action to donate this phosphate group to the ADP so that ADP becomes reformed. Okay, now this ATP will be supplying the required energy to the muscle. And with this phenomena, regeneration of ATP, again the muscle can continue contraction for another 15 seconds. Thereafter, ATP is finished, CP is finished. Now, where from the energy will come? We know in our liver and muscle, we store carbohydrate. Is it true? Is it true? In what form? Glycogen. When the muscle is not acting, relaxing, at rest, when we are sleeping, the blood is having a lot of glucose. This glucose will be taken up by this excess glucose will be taken up by the liver and muscle, and they will convert it into glycogen. Glycogen are just like starch, polysaccharide. And what is this process by which glucose is converted into glycogen? Glycogenesis. Glycogenesis. Genesis production, lysis breakdown. So there will be glycogenesis. So a lot of glycogen will be deposited during resting condition in our muscles and also in liver. So when we will be contracting and beyond 15 seconds, then energy has to be supplied. Otherwise, muscle will not be will not be able to continue its exercise. What to do? It immediately starts producing energy through anaerobic pathway. And that is anaerobic glycolysis. It takes some time. It takes some time. Just after, within 15 seconds, it will be starting. The process has started long back, long before. When I started contracting, the initiation of anaerobic process is started. And within 15 seconds, the result will come. Cell, blood, there is glucose, it will enter into the blood, into cytoplasm. So in the cell, there is nucleus, there is mitochondria, there is cytoplasm. Now, this glucose will undergo oxidation. What type of oxidation? It will be there. What type of oxidation has to be started? It will depend on whether oxygen is present within the cell. Sufficient oxygen is present within the cell or not. If oxygen is present, then there will be aerobic glycolysis. If oxygen is not sufficient, there will be anaerobic glycolysis. We know in presence of oxygen, glucose is oxidized in the cytoplasm into pyruvic acid. And during this process, at substrate level, 4 ATPs are produced. Out of these 4, 2 is utilized. So net production will be 2. See how these 2 are utilized. Glucose first has to be converted into glucose 6-phosphate in glycolysis. Where from this phosphate will come? Breakdown of ATP. So one breakdown gone, 1 ATP gone. Again glucose 6-phosphate, then fructose 6-phosphate, fructose 1,6-diphosphate. Another phosphate is added. Where from this ATP will come? This phosphate will come again from another molecule of ATP. So we know for any production we have to invest money. Then only we will get the product. So initially you have to invest. So initially I invested 2 ATPs and as a result I got 4. So what is the net product? 2. So aerobic glycolysis or anaerobic glycolysis we can get from every glucose molecule we can get 2 ATPs net. This ATP and these reactions that is happening in cytoplasm, it requires only 10-15 seconds. Once started, it will be finished within 10-15. So by this time, it will be able to produce supply ATP. So with this ATP, muscle will contracting. Condition is aerobic. I said aerobic. Sir, in any reaction of glycolysis, there are a lot of reactions in glycolysis. In any reaction of glycolysis, there you won't find anywhere oxygen is used. Okay? So then nowhere oxygen is used in any reaction, then why we bother for the oxygen? What is the need of the oxygen? Can anybody tell? Why we need? You have studied glycolysis. You have studied TCA cycle, Krebs cycle. Are there any need of oxygen? Anywhere oxygen is used in any step? You can't say. Nowhere it is used. TCA cycle happens in glucose. This pyruvic acid will be entering into the mitochondria. There it will undergo TCA, oxidation through TCA cycle. During this oxidation process, we will get ATP, substrate level ATP, as well as we will find some NADH, FADH plus. These are produced, no? From dehydrogenase reaction. The hydrogen atom of glucose is eliminated because what is there in this hydrogen? What is there? The glucose is having hydrogen, C6H12O6. What is there in this hydrogen? Because this hydrogen atom contains energy in its electron shell. Where from this energy came to this hydrogen atom? Where from it got? Who synthesized glucose? Plant. Plant synthesize glucose, C6H12O6, using carbon dioxide and water. So water is having hydrogen, but this hydrogen atom doesn't contain those energy. Then where from this hydrogen energy comes? Sunlight. We know photon is used. Photon is what? Energy. So this photon energy is utilized, incorporated in the, while photosynthesis go on, then this energy is incorporated in the hydrogen electron shell of the hydrogen atom. Now, these hydrogen atoms are incorporated in glucose molecule, and we eat glucose only because of this hydrogen atom, no other purpose. We don't want carbon from here, we don't want oxygen from here. We only want the hydrogen atom for its energy. It is having. Now, how to release this energy? How to extract this energy from the hydrogen atom? See, one of the problems is with you. You learn everything. You learn glycolysis, you learn TCA cycle, you learn electron transport chain, oxidative phosphorylation. Actually, what happens? Why? Why everything is going on? Only to supply you energy. Those energy, to get those energy. That is incorporated to get those energy. Some energy is went to ATP, substrate level ATP, for the formation of the bond, and some energy retained within the atom. Now, what happens? This hydrogen atom carried by NAD and FAD will be entering into electron transport chain for oxidative phosphorylation. Here what happens? There, in this electron transport chain, oxidative, there are several enzymes. This hydrogen atom carried, they are formed here also during glycolysis. They are also found here. So, they can be obtained from TCA cycle from here. So, all these will go to electron transport chain to extract the energy that is the hydrogen atom holding in its electron shell. Okay? So, in the electron transport chain, they will transfer this hydrogen atom to the first enzyme. Say it is NAD, enzyme. So, here, and these are all cytochrome enzymes. These are all cytochrome. Every enzyme is having iron. They are in ferric state. All the enzymes want to become in ferrous state. So now what will happen when this hydrogen atom is transferred to the first enzyme, hydrogen atom, so they will take up the electron. Atom is having one positive and one negative. One positive means electron, positive means proton. This is hydrogen atom. So, when from hydrogen atom electron is separated, what will be there? Is plus. When they will combine, there will be atom. Another atom, H2 plus water and oxygen, H2O. Okay? So this NADH2 will transfer their hydrogen atom to the electron transport chain. Now, the first enzyme getting this hydrogen atom will take the electron. Will take the electron because this electron shell is having the energy. And the proton part, it will say, I don't need you. You go away. You be at my side. But be in the fluid of mitochondria. So now, the first enzyme, after getting these, it will be able to transform itself from ferric state to ferrous state. It is now satisfied. For simplicity of understanding, I am generalizing. What the person sitting by the side of the first enzyme, it is also in ferric state. It also wants electron. So what it will try? It will try to grab that electron from the first enzyme. So there will be a fight. When there is a fight, what happens? Energy, liberation of energy. Now there will be liberation of energy. And this energy is sufficient to combine ADP and phosphate ion to become ATP. See, so in this way, electron is having energy. This electron, when transferring from one enzyme to another enzyme, it evolves energy, and this energy is sufficient to combine ADP and PI to form ATP. Okay? So in this way, when the electron of this is transferred through these enzymes in three sites, there can be generation of 3 ATP in this way. You then transfer it to the second, then transfer it to third, fourth, fifth, and in the process there will be generation of 3 ATP from every FADH2. We know through complete oxidation of one molecule of glucose, we can produce 38 molecules of ATP. Do you know that? While you will be studying this, you have to study the energetics of the pathway. Energetics means accounts. How much you have utilized and what is produced, what is the net gain. There are the energetics. So if you study the energetics of glucose oxidation, you will find one molecule of glucose can yield 38 molecules of ATP, actually 40, minus 2. During first phase of glycolysis, 2 ATP is utilized. So net production is 38. So when glucose is after that, what happened? When this electron, suppose he is the last person in the chain. When he got the electron, this electron is having no energy, nothing. He said, what I will do with this? I cannot transform myself from ferric to ferrous. So I don't require this electron. Where from this electron came? Oh, that hydrogen H plus is there. No? H plus is there. So this electron again will be given to it. Now it will be converted into H. again another molecule of H will come. They may form hydrogen. So within the mitochondria there may be formation of hydrogen gas. No. No way. It cannot be produced, the cell may die. Okay. So what can be done? Okay. You convert it into harmless product. What? H2O. So actually the hydrogen present in the glucose molecule, they are ultimately converted into water. And to make it H2O, oxygen is needed. And that is the purpose of oxygen. Now you think, okay, you are coming from Dharmanagar or airport to city. Lot of car is coming. So there is a blockade at circuit house. What will be happening? The first car will stop. After that, stop. After that, stop. Ultimately, no car will be moving from airport. Okay? Everything will be in a halting position. Here also. If you stop supply of this, what will happen? No formation of water, no electron transport system, it will be blocked, no TCA cycle. Because TCA cycle will be producing lot of NADH2, FADH2. So their amount, NAD, FAD, their quantity is fixed, not enough. So all of them has converted into NADH2, FADH2. They are now unable to release this hydrogen atom. After releasing, they again will be participating in the reaction. So they are not available. As a result, the reactions of the cycle, TCA cycle, will be stopped. Okay. Now come to glycolysis. Here also, what will happen? Glycolysis will not be stopped. Because it also produces NADH2. Now you say, sir, this NADH2 cannot go to mitochondria, it is stopped. So how this NAD will be freed for participation again in the glycolysis? Okay, one way is there. Wait. I will regenerate it within the cytoplasm. How I regenerate within the cytoplasm? This hydrogen, NADH plus, this will be donated to pyruvic acid. After getting this hydrogen, pyruvic acid will be converted into lactic acid. And you lactic acid, you be here, get accumulated, glycolysis will be going on, more pyruvic acid, and what pyruvic acid is not unable to enter in TCA cycle because it is stopped, so it will be producing lactic acid. Why? To regenerate NAD, so that this NAD can participate again and again. So what will be there? If anaerobic and if glycolysis go on in this way, there will be accumulation of lactic acid within the cytoplasm. This is an acid. So if you perform anaerobic oxidation, gradually lactic acid accumulation will double. This is an acid. It will make the medium acidic, pH will be lowered, and we know when pH is lowered or pH is increased, the enzymes loses its activity. Okay, so because of increased concentration of lactic acid in the cytoplasm of the cell will become acidic. As a result, pH will be decreased, and the enzymes of glycolysis and all the enzymes, their activity will be minimum, be gradually decrease. So the glycolysis will be also decreased. So there will be no production of ATP substrate level. As a result, for contraction, I will not be able to get this ATP. So this is called fatigue. What is fatigue? Inability to sustain contraction. So it cannot sustain contraction, it cannot maintain its activity, so there will be development of fatigue. Why this fatigue? Because increased production of lactic acid. Why lactic acid is produced? Because pyruvic acid is converted into lactic acid. Why? To regenerate NAD required for continuation of glycolysis. Okay. What happened? Why NAD is not going to mitochondrial electron transport chain? Because that are blocked in absence of glucose. Now see, you are walking or running at a slow pace. Now question will come, you started walking. So how this energy will come? Who will provide this energy? Which system will provide? So when I am starting, so immediately glycolysis TC cycle will not be started. So what to do? The stored ATP will be utilized. When stored ATP is finished, CP will come forward, and by this time glycolysis process started. So at the end of 13-15 seconds, glycolysis will start yielding ATP. Now, whether lactic acid will be formed or not, it will depend on intensity of the muscular size. Okay? So, my intensity of exercise is such that the requirement of ATP may be supplied by aerobic process only. By aerobic process only. Now, you are utilizing energy by aerobic process. That's why you are breathing. You are utilizing. Breathing means you are breathing for two purposes. To get the oxygen, and after getting the oxygen, you have produced so many carbon dioxide in the TCA cycle. That carbon dioxide has to be eliminated. So purpose is supplying of oxygen to the mitochondrial electron transport chain and to transfer the carbon dioxide produced in mitochondria of the cell and to carry it into the lung. That is the purpose of our breathing, respiration. Now, in low intensity exercise, muscle contraction, the energy fully comes from aerobic sources. Means there will not be any accumulation of lactic acid. Since there is no accumulation of lactic acid, no formation, condition is not anaerobic, so there will not be any formation of lactic acid. So there will not be any fatigue. So if you want to continue walking, you can walk miles after miles, kilometers after kilometers. But even during mild exercise, we need to stop exercise, stop walking, stop running at low pace. What is the cause then? Is it their accumulation of lactic acid? No. That fatigue is because of fatigue can happen anywhere. Suppose you are exercising at low speed, moderate intensity or light intensity work you are doing. Process is aerobic. So your raw material is glucose or glycogen. Now glucose and glycogen may gradually exhausted, may come down. Sufficient oxygen, glucose may not be available to the muscle, to the working muscle. As a result, what will be happening? No glucose, less glucose, so less production of ATP, so you will feel tired. So this is another reason. Exhaustion of nutrient may also cause fatigue. Also, in neuromuscular transmission, what we have seen from the end of the motor nerves. So we are performing these exercises using the motor nerves. These motor nerves are stimulating the muscles and contracting. So from the motor nerves, what is liberated? Acetylcholine. And if you continue this, the amount of acetylcholine in the vesicles may finish, may be exhausted after some time, after repeated contraction, repeated neuromuscular transmission, continuous repeated neuromuscular transmission. So there will be exhaustion of acetylcholine in the vesicles. So in absence of acetylcholine, no transmission, no muscle contraction. So again, you may suffer fatigue. So fatigue can come from exhaustion of acetylcholine in the neuromuscular junction. So several causes. Exhaustion may come from short supply of oxygen. Okay, now you have started another exercise. This is severe exercise, strenuous exercise, like 100-meter sprinting or football playing. Okay, so now what will happen? These activities require a lot of energy. But aerobic system is now unable to provide all the energy, required energy. So now what to do? To continue the energy, to continue the exercise, anaerobic system will also come into action. Anaerobic system will come into action. Now oxygen, ATP produced by aerobic system and ATP produced by anaerobic system will be added. With this, it will continue the exercise. But ultimately, since anaerobic process is going on, there will be accumulation of lactic acid, and after that, the footballer will become exhausted because of accumulation of lactic acid. Again, during rest, what happens to this lactic acid? This is washed away. Again, it is converted back to pyruvic acid, and from this pyruvic acid, it is again converted into glucose by gluconeogenesis, or it will be entering into the TCA cycle. So this is the fate of the lactic acid. Okay, so now we can see for our exercise, depending on the intensity, the source of energy can be ATP phosphogen system, can be anaerobic glycolysis, can be aerobic glycolysis, can be aerobic source or from anaerobic source or both. ATP for the beginning, ATP-CP is needed, and after that anaerobic as well as aerobic pathway is needed. Now you see, you may ask, sir, then fatty acids are not required for giving energy. Then why do we calculate? We say, sir, 1 gram of fat can provide us 9 kilocalorie of energy. We can see, you have explained only glucose is utilized for energy giving. But, yes, fatty acid also can provide energy. You are sitting, no? Not that all the energy is coming from your glucose. Some energy is also coming from fatty acid. How fatty acid gives energy? Anybody? If you perform exercise for, you want to reduce somebody who are obese, no? Overweight, they want to reduce their exercise. So what you suggest? You either you eat less or you do exercise. So what happened if he does exercise? Fat will be burnt. In the adipose tissue, there is fat, triglyceride. The lipase enzyme, during this process, lipase will be broken down. Lipase will break down the triglyceride into fatty acid and glycerol. Now this fatty acid will be liberated from the adipose tissue into the blood. Now the exercising cells, muscles, they will take up this fatty acid and will process it through beta-oxidation for generation of ATP. During beta-oxidation, second line, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Suppose there are 16 carbon. And this 16 carbon compound, they are palmitic acid. Palmitic acid is a fatty acid, saturated fatty acid. Only this carbon, first carbon, it is having 3 hydrogen atoms, CHHH, CH3. And all others are having 2 hydrogen. So they are having 4 valencies. With 2 valencies, they are attaching the 2 hydrogen, and another 2, they are binding the carbon line to their side. So in this way, the last person will be having COOH because fatty acid. So there must be an acidic group. So that group is acidic group. So now this is a fatty acid, and its name is, since it is 16 carbon and saturated, it is nothing but palmitic acid. Now I'll simplify it. Now if it undergoes beta-oxidation, what will happen? First, from that end, I will split 2 carbon, including that carboxylic group. While I have splitted these 2 carbon in the form of acetyl coenzyme A. What I just produced in every beta oxidation, we get 1 molecule of acetyl coenzyme A. And we know this acetyl coenzyme A is a component of TCA cycle. And if 1 molecule can enter within the TCA cycle, it can generate 12 ATPs. How many? 12 ATPs. So now, this is the product of 1 time beta oxidation. So out of 16, 2 I got as acetyl coenzyme and it has produced 12 ATP. Now what I will do? Now there is 14 left. Again the last carbon of this 14th carbon, it becomes acidic. Carboxylic group means coenzyme COA means এটা acyl CoA হয়ে গেল. It comes into acyl CoA. Now again 2 molecules of carbon, 2 carbon will be splitted as acetyl coenzyme. So again this will enter, will produce 12 ATP. In this way, how many times a beta oxidation can take place? Every time 2 is splitted, there are 16 carbons. Every time you want to split 2 carbons. How many times you can do it? Okay? Done? So start beta oxidation. Beta oxidation means beta position. Alpha, in between alpha and beta position, there will be oxidation. And during this oxidation, NADH2 will be formed and the last 2 part will be splitted as acetyl coenzyme. So this is one beta oxidation. This way, how many beta oxidation will be there? 7 times, not 8 times. It is 7 times. So 7 times, how many acetyl coenzyme? 7 times, but how many acetyl coenzyme can be formed? Every time 2. And the last time you will get 4. Last time you will get, suppose he is there with you. These are the 4, last 4. Now if I split here, then how many will be produced? These 2 carbon is acetyl coenzyme, these 2 carbon is acetyl coenzyme. So ultimately, it is 16, no? Half of 16 is what? 8. So 8 molecules of acetyl coenzyme. So 8 into 12, 96. So from one palmitic acid, you can get 96 molecules of ATP. And there will be, every time there will be formation of NADH2. They are also able to produce, as we have seen in electron transport chain, they can also produce ATP. So we will also be getting total 118 or something like that, 108 molecules of ATP we can have from palmitic acid. Sir, very nice. So why should we eat glucose? Let us have fat only. Let us have fat only. Because they can give lot of energy. With this energy, we can perform our functions very easily. So we'll be having, from today we'll be having fat. So okay, go to canteen, mustard oil or ghee, half glass of ghee. Will you be able to eat? No. Firstly, you cannot eat. You will not be able to digest it. Secondly, if you want to get all the energies from the fat only, the one byproduct will be formed. That are ketone bodies. If you use more fat, you will produce more ketone bodies. So there will be ketosis, there will be ketonemia, there will be ketonuria. So you will suffer ketosis. To prevent ketosis, we should not generate all the energies from fatty acids.